So the distance CA is equal to root of 64 plus 100 plus 4 is 168. Any equation of a line which passes through a given point and also parallel to the given vector, both in vector and Cartesian form. This is a Cartesian x minus 5 by 3, y minus 2 by 2 is equal to z plus 4 divided by minus 8 is the Cartesian equation of the line. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, Faculty of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Now, in my previous class, I have discussed regarding the direction ratios and direction cosines of a line. Now, in this session, I am going to take few more problems and the very important derivation equation of a line passing through a given point and parallel to a given vector. Let us come to the first problem. What is the first problem? Show that the point A 2, 3, minus 4 and B 1, minus 2, 3 and C 3, 8, minus 1 are collinear. Now this is very important problem for 3 marks and very easiest problem. Just find out the direction ratios. So find out the direction ratios of the line AB and similarly find out the direction ratios of the line BC. Find out the direction ratios of AB and BC and verify that the direction ratios are proportional. That's it. So let us find out the direction ratios of AB. Now what is A here? A is equal to 2, 3, minus 4 and B is equal to 1, minus 2, 3. So this is x1, y1, z1. This is x2, y2 and z2. Now the direction ratios of line AB is equal to, direction ratios of the line AB is nothing but x2 minus x1 plus comma, this is x2 minus x1 comma y2 minus y1 comma z2 minus z1, that is equal to 1 minus of 2 comma minus 2 minus 3 comma 3 minus of minus is plus 4. So this is minus 1 minus 5 and 7. First line AB, the direction ratios are minus 1 comma minus 5 comma 7. So let us call it as A1 B1 C1. Okay, similarly find out the direction ratios for the line. Similarly the direction ratios of the line BC, just find out for BC. So this is equal to, direction ratios of BC is B, this is x1 y1 z1 x2 y2 z2. This can be written as 3 minus 1, again 8 minus into minus plus 2 and minus 11 minus 3. This is equal to 2 10 minus 14. Now here this, let us call it as A2, B2 and C2. Now the direction ratios of AB and BC are proportional, that is the direction ratios of AB and BC are proportional, that is A1 by A2 is equal to B1 by B2 is equal to C1 by C2, which implies, what is A1 here? A1 is minus 1 divided by A2 is 2 is equal to B1. What is B1? Minus 5 divided by B2 is 10 is equal to 7. C1 is 7 divided by minus 14, which implies minus 1 by 2 is equal to minus 1 by 2 is equal to minus 1 by 2. So the direction ratios are proportional and are equal. So therefore the points A, B, C are collinear. That's all. Therefore A, B, C are collinear. That's it. Ratios of the direction ratios are equal and proportional. So therefore A, B, C are collinear. Very simple. Just find out the direction ratios of the line AB and line BC. The direction ratios of AB is x2 minus x1, y2 minus y1, z2 minus z1, that is nothing but minus 1, minus 5, minus 7. Call it as A1, B1, C2. And similarly, the direction ratios for the line BC, B to C, the 2 points B and C is. So what you are going to get? 2, 10, minus 14, that is nothing but A2, B2, C2. and find out the proportionality. A1 by A2 is equal to B1 by B2 is equal to C1 by C2, that is minus 1 by 2 is equal to minus 1 by 2 is equal to minus 1 by 2. The direction ratios of the line AB and BC are proportional and equal, hence A comma B comma C are collinear. That's it. Okay, hope you followed this. Now let us come to the next problem. Show that the points are collinear. Again same type points. This is A. Let me take A is equal to 2 comma 3 comma 4 and B. What is B? B is equal to minus 1 comma minus 2 comma 1 and C is equal to 5 comma 8 comma 7. These are the points given. Now what is to prove that? To prove that the lines show that the points A, B, C are collinear. To prove that A, B, C are collinear, what is to prove? Just find out the direction ratios of the line AB and BC. Find their proportionality. That's it. Now the direction ratios of AB, line AB is equal to, this is minus 1 minus 2 comma minus 2 minus 3 comma 1 minus 4. This is equal to minus 3 comma minus 5 comma minus 3. Call it as A1, B1, C1. Similarly, find the direction ratios. Similarly, direction ratios of the line BC is equal to this minus this, BC. 5 minus into minus plus 1, 8 minus into minus plus 2, 7 minus 1. This is equal to 6, 10 and 6. Let us call it as A2 comma B2 comma C2. Now find out the ratios. So therefore A1 by A2 is equal to B1 by B2 is equal to C1 by C2. This implies, what is A1? Minus 3 divided by A2 is 6 is equal to B1 is minus 5 by 10 is equal to minus 3 divided by 6. So this can be written as minus 1 by 2 minus 1 by 2 minus 1 by 2. So here the ratios are proportional and equal, therefore A comma B comma C are collinear. A, B, C are collinear. That's it. So find out the direction ratios of the line AB and BC and check whether they are proportional and equal. Therefore A comma B comma C are collinear. That's it. Now let us come to the next problem. What is the next problem? Find the direction cosines. So it is required to find the direction cosines of the sides of a triangle whose vertices are given. A, B, C are given. The vertices A, B, C are given. What is required to find is the direction cosines. So to find the direction cosines of the triangle, let us first of all find out the direction ratios. So the direction ratios of the lines AB, BC and AC. Okay, now let us draw the triangle first. This is the given triangle ABC. What is A? A is 3 comma 5 comma minus 4. A. B. B is equal to minus 1, 1 and 2. C. What is C? Minus 5 and minus 2. Now first find out the direction ratios. Direction ratios, the direction ratios of the line AB. Direction ratios of AB is equal to, so that is x2 minus x1 comma y2 minus y1 comma z2 minus z1. So this is equal to AB. This is x1 y1 z1 and this is x2 y2 z2. Minus 1 minus 3 comma 1 minus 5 1 minus 5. Again 2 minus into minus plus 2 plus 4. This is equal to minus 4 comma minus 4 comma 6. Okay. Now, so this, let us call it as A, B and C. A comma B comma C. In the previous classes, we already studied to find the direction cosines of a line joining the 2 points x1, y1, z1 and x2, y2, z2. The direction cosines of a line joining the 2 points is x2 minus x1 divided by its own length of AB, y2 minus y1 divided by AB, and z2 minus z1 divided by AB. Here also, the direction cosines of AB is x2 minus x1 by AB, y2 minus y1 by AB, and z2 minus z1 by AB. What is AB? AB is nothing but the distance between the 2 points. So, here the distance between the 2 points is given by the square root of 4 square is 16. Again, 4 square is 16 plus 6 square is 36. So, this is equal to 16 plus 16, 32. 32 plus 36, 68. Square root of 68. Split it. Now, this can also be written as 17 fours of 4, 17 into 4. So, this can be written as 2 root 17. So, therefore, the distance AB is equal to 2 root 17. Now, therefore, the direction cosines of AB are the direction cosines of AB. Therefore, the direction cosines DCS of the line AB, the direction cosines of the line AB is equal to, what is this equal to? Minus 4 divided by 2 root 17, comma, minus 4 divided by 2 root 17, comma, 6 divided by 2 root 17. That's equal to, divide it, 2 to the gets cancelled, minus 2 by root 17, comma, minus 2 by root 17, comma, 3 by root 17. These are the direction cosines. So, the direction cosines of AB is minus 2 by root 17, minus 2 by root 17, and 3 by root 17. Okay. Similarly, find out the direction cosines of AB, BC, and AC. That's all. Now, come to this. Now, the direction cosines of BC. Now, similarly, the direction cosines of BC is, what is B? B and C. What is B? B, minus 1, 1, 2, minus 1, 1 and 2. What is C? Minus 5, minus 5, minus 2. Now, this is nothing but, find out the distance BC first. BC is equal to root of minus 1 minus into minus 5 whole square plus 1 minus into minus plus 5 whole square plus 2 plus 2 whole square. This is equal to root of 4 square plus 6 square plus 4 square. This is nothing but 4 4s are 16, 6 6 are 36 plus 4 4s are 16. Root of the same thing we are going to get, that is nothing but 36 plus 32, that is nothing but 68. This is nothing but 17 into 4. This is equal to 2 root 17. The direction cosines of BC is x2 minus x1, that is nothing but minus 5 minus into minus plus 1 divided by 2 root 17, comma, minus 5 minus 1 divided by 2 root 17, minus 2 divided by 2 root 17. So, this is equal to minus 4 by 2 root 17, minus 6 by 2 root 17, minus 4 by 2 root 17. This is equal to, divide it, minus 2 by root 17, minus 3 by root 17, and minus 2 by root 17. So, these are the direction cosines of the line BC. Similarly, find out the direction cosines of the line AC. That's it. That is the required answer. Okay. Hope you followed. Similarly, find out the direction cosines of CA. Similarly, the direction cosines of CA is equal to, find out the distance from C to A. CA is equal to root of, what is C? C, minus 5 minus 2, and A is 3 5 minus 4. So, CA is nothing but minus 5 minus 3 whole square plus minus 5 minus 5 whole square plus minus 2 minus of minus is plus 4 whole square. So this is equal to minus 8 square plus minus 10 square plus 2 square. This is equal to root of 8 8s are 64 plus 100 plus 4, root of 168. Root 168. So this is direction cosines. The direction cosines, to find the direction cosines, first find out the direction ratios. Let us find out the distance. So the distance CA is equal to root of 64 plus 100 plus 4 is 168. 168 can also be written as, this can be written as square root of 4 into 42. So square root of 4 into 42, 2 root 42. 42 into 4. 4 2s are 8, 4 4s are 16, 168. So the direction cosines of this CA is equal to, I will write here, that is minus 8 divided by 2 root 42, comma, minus 5 is minus 10 divided by 2 root 42, comma, 4 minus 2 is 2 divided by 2 root 42. So this can also be written as, so this is also equal to, the direction cosines of CA can also be written as, the direction cosines DCS of CA is also equal to, if you want you can divide 2 2s are, this is minus 4 by root 42, comma, 2 5s are 10, minus 5 by root 42, comma, 2 2 gets cancelled, 1 by root 42. So these are the direction cosines of the lines AB, BC and CA for the triangle ABC. Just find out the direction ratios and divide by the distance, that will give the direction cosines. That's it. Very simple problem. Now let us come to the next problem. Very important thing. So the derivations. Now equation of the line in space. So this is very important for 5 marks. You will get 1 5 marks derivation from this equation of a line. So let us come to the line first. So equation of a line in space. A line is uniquely determined if it passes through a given point and has a given direction. So a line is uniquely determined if it passes through a given point. If a line passes through a given point and has a given direction, or if it passes through 2 given points. Okay, here it passes through the given point and has a given direction. The second one, or if it passes through any 2 given points, then we are going to find the equation. Now let us come to the first derivation. This is very important for 5 marks. 5 marks definitely will expect this type of question. Definitely will get this question for your annual examination. What is the question here? Derive the equation of a line in space passing through a given point and parallel to the given vector. So equation of a line passing through a given point, any equation of a line which passes through a given point and also parallel to the given vector, both in vector and Cartesian form. So in the examination they may ask, derive the equation of a line passing through a given point and parallel to the given vector, both in vector and Cartesian form. Now let us derive this, the proof. Now let us come to the proof. So the diagram is very important. In the examination you should have to write the diagram. If you do without diagram, you won't get the marks. So the diagram is very important. Now equation of a line through a given point and parallel to a given vector. Proof. Now let us consider, let A be the position vector of the given point. Now let us consider a point A whose position vector is A. So therefore OA is equal to vector A. Let us consider a point A with position vector OA is equal to vector A. Now let A be the position vector of the given point A with respect to the origin of the rectangular coordinate system. Let A, capital A. So here let small a be the position vector of the point A with respect to the origin O of the rectangular coordinate system. Therefore the vector OA is equal to vector A, small a. Now let L is the line, let L be the line which passes through the point A. Let L is any line which passes through the given line, which passes through the line A. So let L be the line which passes through the point A and is parallel to the given vector B. Okay, here L is any line which passes through the point A and that line is parallel to the given vector B. So here AP is the line L. This line is parallel to the given vector. So vector B. Now then let R be the position vector on the arbitrary point P on the line. So this R is the position vector. So therefore vector OP is equal to vector R. OP is equal to vector R. So this is the construction part. Listen to me here, very simple and very important. Let A, small a be the position vector of a point A. Therefore vector OA is equal to A. So that is, let A be the position vector of a given point A with respect to the origin of the rectangular coordinate system. Let the line L which passes through the point A. So therefore AP is the line which passes through the point A and is parallel to this line is parallel to the given vector B. So a line L is parallel to the given vector. That is what we want to determine. Equation of a line passing through a point and parallel to the given vector. So here this line will pass through the point A and parallel to the given vector B. So then let R be the position vector. This R be the position vector of the point P. Therefore vector OP is equal to vector R. This is the construction. Consider a line L which passes through a point A and the position vector of OA is vector A and the line L AP is parallel to the vector B. Let the position vector of the point P is OP is equal to vector R. That is the construction part. Okay. Now come to the next line. Since AP is parallel to this line AP, the line L is parallel to the vector B. AP is parallel to vector B. AP is parallel to vector B. Therefore AP is equal to lambda into vector B, where lambda is some real number. So since vector AP is parallel to vector B, therefore vector AP is equal to lambda into vector B, where lambda is a real number, where lambda is some real number. You know AP can also be written as vector OP minus vector OA is equal to lambda into vector B. Since we know what is OP here, OP is equal to vector R, and what is OA, OA is equal to small a. Vector OP is equal to R and vector OA is equal to vector A. Substitute the values. Vector OP is equal to R minus vector OA is equal to A is equal to lambda into B. What is required to find is R. Just keep R here itself and transfer lambda B minus A becomes plus A. Therefore vector R is equal to A plus lambda into B is the equation of the line in the vector form. This is the equation of the line in the vector form. So the vector form, equation of a line which passes through a given point and parallel to the given vector is R is equal to A plus lambda into B in the vector form. So the vector form of an equation of a line is R is equal to A plus lambda B. That's it. This is first part of the derivation. Listen to me, very important, very simple. Let us consider a line. Let vector A be the position vector of a point A. Therefore vector OA is equal to A with respect to the origin of the rectangular coordinate system. Let L be the line which passes through the point and is parallel to the given vector, vector B. Now therefore the position vector of the arbitrary point P is given by vector OP is equal to R. Now since the vector A, the line AP is parallel to the vector B, that is the line LAP is parallel to the vector B. Therefore we have AP is equal to lambda into B. AP can also be written as OP minus OA is equal to lambda into B. Substitute the values. What is OP? The position vector of P is R and OA position vector of A is vector A is equal to lambda B. R is equal to lambda B plus A, or R is equal to vector A plus lambda into vector B is the vector form. So therefore vector R is equal to vector A plus lambda B is the vector form for the equation of a line. Okay, this is the vector equation. Now find out the Cartesian form. Just since this is the point and here this point is considered as x, y, z, and the position vector of this is nothing but x1, y1 and z1. So just simplify, you will get the answer. That's it. Here what is R? R is equal to xi plus yj plus zk. What is vector A? x1i plus y1j plus z1k. What is vector B? Vector B can be taken as ai plus bj plus ck. Simplify, you will get the answer. Now let us derive the second part. Now the Cartesian form. So for the Cartesian form, let the coordinates of the point A be x1, y1 and z1. Let the Cartesian form the coordinates of the point A be x1, y1 and z1. For this point A, the coordinates are x1, y1, z1. Therefore, the position vector of A is vector OA. Therefore, vector OA is nothing but vector A is equal to x1i plus y1j plus z1k. This is vector A. Okay. Find out vector A. Let P, x, y, z be any point on the line. Let P, x, y, z be any point on the line. Therefore, OP is nothing but vector R. So, let P, x, y, z be any point on the line L. Therefore, vector OP is equal to vector R. So, vector R is equal to xi plus yj plus zk. Now, let the direction ratios of the line L, let A, B, C are the direction ratios of the line. Now, therefore, vector B is equal to AI plus BJ plus C into vector K. So, these are the given conditions. Now, listen to me here. So, to find the Cartesian form of the equation of a line, let the coordinates of the point A be x1, y1, z1. So, therefore, the position vector OA is equal to vector A is equal to x1i plus y1j plus z1k, and let P, x, y, z be any point on the line L. So, therefore, vector OP is equal to R, that is vector R is equal to xi plus yj plus zk. Let L, M and N, or let A, B, C, let A, B, C are the direction ratios. A, B, C are the direction ratios of the line. Therefore, vector B is equal to AI plus BJ plus CK. So, if you want, you can also consider L, M, N as the direction cosines. Now, therefore, from vector equation, from vector form, R is equal to vector A plus lambda B. What is vector R? Vector R is nothing but vector R is equal to, this implies vector R is equal to A. What is A? A is equal to x1i plus y1j plus z1k plus lambda into vector B. What is vector B? AI plus B into J plus ABC into K. Now, what is R? R is nothing but xi plus yj plus zk. Okay. Now, simplify this, you will get the answer. That's it. Okay, I will go to the next page. Therefore, what is R? R is equal to xi plus yj plus zk. Therefore, xi plus yj plus zk vector is equal to x1i is equal to x1i plus y1j plus z1k plus lambda into ai, a into I, b into j plus c into k. Now, just transfer this. This can be written as xi minus x1i plus yj minus y1j plus zk minus z1k is equal to lambda ai plus lambda into bj plus lambda into ck. So, therefore, this can be written as x minus x1 into I plus y minus y1 into j plus z minus z1 into k cap is equal to, this is lambda A into I cap, lambda B into J cap plus lambda C into K cap. Now equating the coefficient of I, J, K. So x minus x1 is equal to lambda A, y minus y1 is equal to lambda into B, and z minus z1 is equal to lambda into C. So this can be written as x minus x1 by A is equal to lambda, and y minus y1 by B is also equal to lambda, and z minus z1 by C is also equal to lambda. So therefore x minus x1 by A is equal to y minus y1 by B is equal to z minus z1 by C is called the equation of a line in Cartesian form. Cartesian form of a line. This is the Cartesian form of a line. That's it. Just substitute the values in R is equal to A plus lambda B. From this, R is equal to A plus lambda into B. R is xi plus yj plus zk. A is x1i plus y1j plus z1k. Lambda into vector bj plus ck. Now just subtract this, x minus x1i, y minus y1j plus z minus z1k is equal to lambda into ai plus lambda into bj plus lambda into ck, equating the coefficient of I, j and k. So x minus x1 is equal to lambda a, x minus x1 by a is lambda, y minus y1 by b is equal to lambda, z minus z1 by c is also equal to lambda. So therefore the combined equation is x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c is the equation of the line in the Cartesian form. Suppose if LMN are the direction cosines, if LMN are the direction cosines, if LMN are direction cosines, then the equation of a line can also be written as x minus x1 by L is equal to y minus y1 by M is equal to z minus z1 by N. So provided LMN are the direction cosines. Okay, this is the equation of a line. That's it. Very, very important. Practice this. Definitely you will get this derivation. Either the problem for 3 marks. Now, let us take few problems based on this. Let us consider an example. This is very important for 2 marks. Find the vector and Cartesian equation of the line through the point. So, equation of a line passing through the point and parallel to the given vector. Now, let us write down what is the given condition. Now here the equation of a line passing through the point. What is the point here? The point passing through the point 5 comma 2 comma minus 4. So therefore this can be written as vector A is equal to OP. This is vector A is equal to 5i plus 2j minus 4k. And parallel to the given vector, vector B is equal to 3i plus 2j minus 8k. This is the given condition. Vector A is 5i plus 2j minus 4k and vector B is equal to 3i plus 2j minus 8k. Now the Cartesian equation is therefore the first one, the vector form. Let us come to the vector. The vector equation of line is vector R is equal to A plus lambda into vector B. What is vector R? Vector R is equal to A. A is 5i plus 2j minus 4k plus lambda into vector B is 3i plus 2j minus 8k. This is. So simplify this, you will get the answer. That's it. So here what is given? Vector A is equal to the point 5i plus 2j minus 4k and vector B, the parallel vector is 3i plus 2j minus 8k. The vector equation of the line is vector R is equal to A plus lambda into B. R is equal to 5i plus 2j minus 4k plus lambda into vector B is 3i plus 2j minus 8k. Simplify this, you will get the answer. Therefore, we can write, if you want you can stop here itself. R is equal to 5i plus 2j minus 4k plus lambda into 3i plus 2j minus 8k, or if you want you can put what is R, xi plus yj plus zk is equal to, this is 5i plus 2j minus 4k plus lambda times 3i plus 2j minus 8k. This is the vector equation. Now second, for Cartesian form, equation of line. For the Cartesian equation of line, so what is the Cartesian equation of the line? X minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. Now what is here given? So this is vector x1 y1 z1. x1 z1 y1 is nothing but the point 5 comma 2 comma minus 4, and a b c is nothing but this is vector a is equal to 3, b is equal to 2, and c is equal to minus 8. This is x minus 5 by 3 is equal to y minus y1 is 2 divided by 2 is equal to z minus into minus is plus 4 divided by minus 8. This is the Cartesian equation of the line. Okay. What is the Cartesian? X minus 5 by 3, y minus 2 by 2 is equal to z plus 4 divided by minus 8 is the Cartesian equation of the line. Or otherwise, you can also simplify like this, or this is xi plus yj plus zk is equal to, what is the previous equation we got? So that is 5i plus 2j minus 4k plus lambda into 3i plus 2j minus 8k. Now transfer this, that is x minus 5 into I plus y minus 2 into j plus z minus into minus plus 4 into k is equal to lambda into 3i plus 2j minus 8k. Equating the coefficients, x minus 5 is equal to 3 lambda, y minus 2 is equal to 2 lambda, and z plus 4 is equal to minus 8 lambda. So therefore x minus 5 by 3 is equal to lambda, y minus 2 by 2 is equal to lambda, and z plus 4 divided by minus 8 is equal to lambda. Therefore we can write x minus 5 by 3 is equal to y minus 2 by 2 is equal to z plus 4 by minus 8. This is the Cartesian form of the line, one and the same. Now let us come to the similar problem. Find the equation of the line which passes through the point 1, 2, 3 and parallel to the vector. This is vector b and this is vector a. That's it. Now let us come to the solution. What is given? Vector a is equal to I plus 2j plus 3k, and vector b is equal to, what is vector b? This is given 3i plus 2j minus 2k. Now the first one, vector equation. Vector equation of line is, vector equation of line is vector r is equal to a plus lambda into vector b. That is vector r is equal to a. A is I plus 2j plus 3k plus lambda into vector b is 3i plus 2j minus 2k. This is the vector equation. That's it. See, what is given? A is equal to 1, 2, 3 means I plus 2j plus 3k, and vector b is equal to 3i cap plus 2j cap minus 2k cap. The vector equation of the line is vector r is equal to a plus lambda b, r is equal to a plus lambda into vector b. Now, to find the Cartesian form, second part, Cartesian form of line. Cartesian form of line is x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. So this is nothing but x1, y1, z1, and this is a, b and c. X minus x1 is 1 divided by a is 3, y minus y1 is 2 divided by 2 is equal to z minus 3 divided by minus 2. That's it. Or if you want, you can also write x minus 1 by 3. So if you simplify this, this is nothing but xi plus yj plus zk is equal to the same thing. You are going to get, that is vector I plus 2j plus 3k cap plus lambda into 3i plus 2j minus 2k cap. So x minus 1 divided by 3, y minus 2 divided by 2, and z minus 3 divided by minus 2. The same thing we are going to get. That's it. Now let us come to the next problem. Find the equation of a line in the vector and Cartesian form that passes through the point with position vector 2i minus j plus 4k is in the direction of vector I plus 2j minus k. So here the position vector and the direction are given. That's it. So here the position vector means, therefore what is given? A is equal to 2i minus j plus 4k, and vector B is this, I plus 2j minus k. Now the first one is Cartesian vector form, the vector equation. Vector form of line is vector r is equal to a plus lambda into b. So that is vector r is equal to, what is a? A is 2i minus j plus 4k plus lambda into vector b. Vector b is I plus 2j minus k. This is the vector equation. Now for the Cartesian equation, Cartesian form of the line is x minus x1 by a, y minus y1 by b is equal to z minus z1 by c. So the Cartesian form is x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. So therefore x minus x1. So what are the values of x1? This is x1, y1, z1. X minus x1 by a is 1 is equal to minus into minus plus divided by 2 is equal to z minus 4 divided by minus 1. So x minus 2 by 1, y plus 1 by 2, z minus 4 by minus 1 is the required equation of the line in the Cartesian form. Okay. Now let us come to the next problem. Find the Cartesian equation of the line which passes through the point minus 2, 4, 5 and parallel to the given line. Parallel to this given line. X plus 3 by 3, y minus 4 by 5 is equal to z plus 8 by 6. Okay. So find the Cartesian equation. We have to find the Cartesian equation which passes through the point minus 2, 4, 5 and parallel to the given line. Okay. Now listen to me. What is given? The given points are, what are the given points? Minus 2, 4, minus 5. And what are these 3, 5 and 6? The direction ratios. The direction ratios are, 3, 5, 6. These are the direction ratios. Now what is required to find? Find the Cartesian equation of the line which passes through the point and parallel to this. So therefore the Cartesian equation of line is x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. So here what are the points? These are the points x1, y1, z1. So this is x1, y1, z1. This is a, b and c. Substitute here x minus into minus plus, x plus 2 divided by a is 3 is equal to y minus 4 divided by b is 5 is equal to z minus into minus plus 5 divided by 6. This is the required answer. X plus 2 by 3, y minus 4 by 5 is equal to z plus 5 by 6. So this is the required equation and parallel to the given line. See here, very simple problem. Find the Cartesian equation. The Cartesian equation of the line is x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. So which passes through the point. What are the points? Minus 2, 4, minus. So therefore the points minus 2, 4, 5 is nothing but x1, y1, z1. And parallel to the given line. What is the line? X plus 3 by 3, y minus 4 by 5, z plus 8 by 6. First, just find out the direction ratios. The direction ratios are 3, 5 and 4. This is nothing but ABC. So the required equation of the line is x minus x1 by a, x plus 2 by 3, y minus y1 by b, y minus 4 by 5 is equal to z plus 5 by 6 is equal to a constant. That's it. This is the required equation of the line. Hope you followed this. So these are few problems based on the first derivation, equation of a line passing through a given point and parallel to the given vector. In vector form is r is equal to a plus lambda b, and in the Cartesian form is x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. So the vector equation is r is equal to a plus lambda b, and the Cartesian equation is x minus x1 by a, y minus y1 by b is equal to z minus z1 by c. This is very important derivation. You may get the derivation for 5 marks, or definitely you will get one problem for 3 marks, either derivation or problem. Practice this, very important, very important. That's all for today's session. Let us meet with the second derivation, equation of a line passing through 2 points, in the next session. Thank you very much.